Hey everybody, welcome back to Jim's Garage. In this video, we're going to be starting our mini-series on gaming, first focusing on setting up the big guns, Pterodactyl. Now, Pterodactyl is a way of hosting multiple games through a friendly and convenient web user interface. Now, I do realise that there is Pelican, which has been spun up by some of the devs splintering from Pterodactyl, but from everything I can see, Pterodactyl is still supported, the ecosystem is still healthy, so we're going to go ahead and set it up in this, but I definitely will be checking out Pelican in subsequent videos. So one of the reasons you might want to set up Pterodactyl is it gives you a convenient all-in-one solution for setting up your game servers. So absolutely, you can go and set up individual servers using Docker Compose or binary files. I will be doing that later on. But if you want something that's all contained in one user interface, in one sort of platform, then Pterodactyl is a great choice. Now, the way it works is a bit probably analogous to Docker Swarm or a super light version of Kubernetes. Typically what you have is you set up the user interface, it's called the panel, and then off the panel you set up what are known as wings. I guess a play on the pterodactyl analogy. Now the wings are effectively separate Docker instances, and you basically can scale up the number of wings you want as you increase the number of servers that you need. So think of it as a way of adding new machines, they can be either virtual or physical, to your existing Pterodactyl setup. In this video specifically, I'm going to be using a single Docker host. We're going to put both the panel and the wings onto the same virtual machine. We're going to put all of that behind a traffic reverse proxy so that we can basically forward everything with SSL, which is nice to see. You can check out my videos on traffic if you need to, but do bear in mind you don't have to set it up in the way I am. You could use a different proxy, for example, or you could set it up so that the wings are all discrete physical machines or virtual machines. It's totally up to you. The good thing is you can probably take the steps that we're going to go through in this video and apply it to whatever infrastructure setup you want. Anyway, I'm going to shut up now and we're going to get into deployment. So a prerequisite that I recommend is Portainer. That's going to make this whole process a lot easier. We're going to be able to see logs, we're going to have a nice user interface, and we can even dive into the containers if we need to. If you're a bit more of a pro, you don't have to use it, but I do recommend it. So if we head over now into Visual Studio, you can see here that I've got the Docker Compose file that we need to set this up. Now, there are a number of ways that you can set this up, but this is the way that I have it running. And as another prerequisite, you will have to have traffic for this setup, but as I mentioned earlier, you can use other reverse proxies. There isn't in fact any documentation for traffic, so I've had a bit of trial and error to get this working, but standard things like Caddy and Nginx, you will find instructions for those on the official website. So if we work through this quickly, just looking at the containers, I'll give an overview of what they do, and then we'll have a quick comb through and actually find out how this is all pinned together. So at the top, we've got a MariaDB. So we have a database that will store a lot of the things for the panel, all the configs and all the details for all the nodes, etc. We're using a Redis for cache, so that uses memory storage basically to make things nice and snappy. Then we've got the panel. So that is the web user interface that you will be using to control all of your nodes and servers. And then finally, we've got the wings itself. Now, I put this all into one Docker Compose file, but you could split this out if you wanted to. The wings, as I said before, is effectively another Docker instance that runs all of the servers. Also at the bottom, we've got the networks, and this can be a little bit confusing, so I will go through that in more detail in a minute. So back up at the top, the key thing really for the databases is we need to set it up with some variables for setting the initial usernames and passwords, and we'll be running a command later on which will allow us to put in a default admin so that we can log in. Now, the important thing here is this just needs to go on what I've called the Pterodactyl network. So again, this is just an internal network within Docker that only these containers will have access to. Similarly with Alpine, there's not really anything here to discuss. We're going to put that on the Pterodactyl network so that the panel and the database can use it if needed. Typically for a small setup within a home lab, this isn't important, but if you want to start scaling this up, then something that can write to memory is going to be much more performant. Next, we move on to the panel, which is the web user interface. Now, there's nothing really to see here. other than we can get rid of the ports because I'm running this behind a reverse proxy. If you're not, you can obviously uncomment that, and then you'll be able to access it through the IP address and the respective port. We've got some volumes where we need to store some of this data because we want persistence between reboots. For environment variables, they're pretty self-explanatory. We've set the time zones, we've set a URL. Now you're going to need to make sure that this DNS is resolvable. So whatever you're using for your DNS resolver, I use Pi-hole. I've put this into Pi-hole so that it resolves to the IP address of my Docker VM. You can go ahead and set up SMTP if you want to, so that you get emails with your passwords, etc. You don't have to do that. I've said that the trusted proxies are for everything at the moment. If you wanted to restrict that, you could put in here a list of IP addresses. We've set the database host and the port and the password that was specified further up. You could substitute in here some Docker environment variables if you wanted to make that simpler, but I've just left it in here. And we've also specified that we want the panel to make use of Redis, and we've set that just here. Now, Let's Encrypt, I'm not going to be using that, albeit you can use Let's Encrypt on the panel itself. What I mean by that is, as you can see down here, I'm doing all of the SSL offloading at the proxy. So Traffic is handling all of my Let's Encrypt, but maybe if you wanted a bare bones installation, you could let Pterodactyl itself handle all of the SSL certificates. So it can go and pull your cert for you. Now for the networks, because I'm running this on my Traffic, that network is labeled as proxy. You can find that in a previous video. And I've also added it then onto this Pterodactyl network so that it can communicate with all of the other containers in this stack. In terms of the traffic labels, there's nothing really here to report. Just we're specifying that it in the back end is running on port 80. Next, we get onto the wings. And as I mentioned, you can split this out if you want. For the wings, the important bit really here is this port here of port 2022. That's for SFTP communication between the wing and the panel. Now you can obviously change all of the user IDs to whatever you want for security reasons. This is just going to run as my local user. And then we get onto the volumes again, which is a really important part. Now this does have the Docker SOC enabled, so if this were to be compromised, that could be a security risk, so do bear that in mind. Next, we actually specify the containers for where all the Docker volumes sit. And what actually happens with Wings is, because you've given it access to the Docker SOC, I'll show this later, when you spin up a server, we're going to spin up a Minecraft server using Pterodactyl, you'll actually see that because it's got control of the SOC, Wings will actually spin up a new container and we'll be able to visualize that within Portainer. After that, we've got various volumes for things like the etc. This is where the configuration file will be set. We'll come onto that later in the video. We've got the varlib Pterodactyl. That's where some of the data will actually sit. We've got the logs, we've got a temporary, and then we've also got the certificates, but we're not actually going to be using those, but I've just left those in there. There's no harm. If you wanted to not use a proxy and you wanted to the certificates yourself, you could uncomment this part up here and then put the certificates in this expected location down here. Now for the networks, it's going to sit on the proxy so that we can actually access this again through SSL, make sure that that's secure, but it's also going to spin up a new network called Wings 0. Now for each wing that you spin up, this is Wing 0. For example, if you wanted another wing, you'd probably call it Wings 1. You would have another separate network. Now the reason you do that is because it's kind of Docker in a sense. Every server it spins up is going to want to be on its own non-overlapping address space. So each one should have a unique address space, and I'll come onto that later in the video. It sounds complicated, it's really not that complicated, and Portainer makes it a lot easier to visualize. After that, we've got some standard labels for traffic. The only one really that matters too much is that we're going to be running this on port 443 so that we can take advantage of SSL. Now we'll need to specify that later on, and I'll show you exactly where that gets specified. Next, we've got the network, so we're just creating Pterodactyl. We've got proxy and it's external true. External true means that it's being created before this Docker stack, so it's been created elsewhere. And then we've got the wings. So for the wings, I've created a new bridge network, and I'm going to give it the subnet of 172.50/16. Now you might be thinking, why am I doing that? There's no reason for that specific number, but if I go back to Portainer and I click on my server, if I go over to the networks here, you'll see that I've just picked basically a range that hasn't been used. So don't just blindly pick the 50 that I have a look in Portainer and just check for a network range that isn't already in use. Now that we've done that, we are pretty much ready to go. So we should be able to go away now and run this and get it spun up. So let's head into the terminal, let's navigate to where this compose file is, and let's see what happens. So I've navigated to the Docker Pterodactyl folder, and here you can see the compose file. So if I do a sudo docker compose up-d, we should be able to start this working. Now what's going to happen here is it's going to create and pull all of the containers, so pulling down those images, and it's also going to go away and create the networks. So you can see it's creating the networks, and now it's creating and starting all of those containers. Yours will probably take a bit longer to start up because I've already pulled down the images, but it should end up exactly the same as this. Now, with that in mind, let's head back to Portainer and we'll head over to our containers. And now if I scroll down, we should see here we've got the database, we've got the panel, we've got Redis, and we've got Wings. Now, I'm going to have a look at the panel first. Now, the panel will be waiting for a database connection. Don't get concerned if it's taking a little while. That's because if we go into the actual database itself, you'll see that that's not quite up and running yet. And we need to wait until it says that the connection's ready to be initiated. Once that's ready for connections, what will then happen is the panel can connect to the database and can start initializing all of the tables. I'll just leave it here for a second and skip until it starts doing that. And so now you can see that it's actually connected to the database and it's now doing all of the creation of the migration tables. This will take probably 10-15 seconds to complete, but once that's completed, we're ready to move on. Whilst it's doing that in the background, let me just show you what's happening in the other container, that is the wing. So when we see this, we're going to see an error. And that's because, as I mentioned earlier, we need to specify a configuration file, specifically the etc pterodactyl config.yml. Now, we can't do that until we've set up a few things within the web GUI, but hopefully now if we hop back into the container for the panel, that should be up and running or nearly finished. That's nearly done. I'm going to skip ahead now until it's completed, and once that's completed, we're ready to then get into the web UI. So now that's completed and we can see the final entry is that the server is running without any HTTP authentication. So that might sound bad, but obviously we've got this running behind traffic, so we don't have to worry about that. Now I've added panel.jimsgarage.co.uk to my Pi-hole so that I can resolve its DNS internally. That means now that I can go to that URL and access the page. So going to panel.jimsgarage, we're greeted with the login page for Pterodactyl. Now we can't actually log in yet because we haven't created a default user, but there's a handy command that we can do that to pipe a user into the database so that we can log in. So back into our terminal, the command to do that is the following. We're going to do a docker compose run. We're going to use the panel for PHP artisan. So we're going to do a user make, so make a user. The email address I've said for that is just admin@jimsgarage. The username is going to be called admin. The name is just admin. Last name is user. Password admin. And then I've said admin, no password. Now, obviously you can change this to something far more secure. I'm just keeping this super simple to get it up and running. So now if I run this command, what it's going to do is basically create a temporary container, spin it up, and then execute into the database. You can see it connecting there to the DB, and it's going to create all those necessary entries so that we can log in. Now that that's completed, all being well, we should be able to head back now to Pterodactyl. So if I log in with admin and hit return, we should be greeted with the first page. So all of that looks good, and as you'll notice, we have a nice secure connection up in the browser. So when you first log in, there's not really much to see. What we need to do is go into the admin panel, and here you can see all of the settings for your server. Now at the moment we don't have anything here. We don't have any locations, we don't have any nodes, we don't have any servers, and we don't have any other users. So let's go and remedy that now. So the first thing we need to do is to set a location for this panel. So we simply need to go to locations, create new. Now as you can see from earlier, I'm just going to call this one home. You could have multiple panels all with different names and you can give them handy descriptions if you want. You could have this say in the cloud. But once that's created, we can move on to the next step. The next step then is basically to create a node. Now the node is that Wings server that isn't doing anything at the moment. So what we need to do is click create new. Now if you remember from the Docker Compose file, I just called mine Wings 0. And you can also give that a description. And now that we've got a location set, you can basically pin it to that home location. So if you had more than that, you could say, hey, this Wings is part of a different location. Now for the node visibility, I'm leaving that to public. And for the FQDN, you remember from the Docker Compose file that I had in here in the traffic labels, wings0.jimsgarage.co.uk. Now for that to work again, you're going to need to have that FQDN in your DNS resolver, and specifically you're going to need to make sure that your Docker hosts can all reach that resolver. So in here I'm going to put wings0.jimsgarage.co.uk. We're going to use an SSL connection, and the important bit here is we are behind a proxy, we're behind traffic. Now for the rest of this, you pretty much want to leave as is for the volume directory. You can change this, but you're going to have to go back and change all of your Docker Compose file as well. Plus you'll need to change the config file, which we'll get onto in a minute. Now the total memory, this is just a test server, so it's quite anemic. I'm just giving it 2000 megs of memory, and I'm not allowing it to over allocate, but obviously you can tailor this to whatever you want. If you have beefy VMs, you can obviously max this out, or if you've even got some dedicated tin that you're going to put this on, you could probably get several gigabytes of memory and disk space on there. Now the other important thing we need to change here, if you remember, is 443, because we're running this behind a reverse proxy with SSL. The daemon port is going to be 2022, and if you remember from the Docker Compose file, that's the port that we specified, which is exposed. Now you can just see above my head there's a green button here for create the node. I'm going to click that button, and fingers crossed everything goes to plan, and yeah, successfully created a new node. Now you might be thinking, what's this page? Allocation. Well, the first thing we need to do when we create a new node is to say what IP addresses it can use and what ports. Now you might be thinking, what's actually going on here? Well, every time this wing, remember this is its own sort of small Docker instance, sets something up, it needs to have an IP address so you can connect to it, and you're going to need a port. So the way I've done this, and you don't have to do it, but it makes it simple, especially when you've only got one interface on your containers, is to set the IP address to 0.0.0.0. So it's just actually going to bind to everything. Now, if you have something a bit more exotic, you might have a virtual machine with lots of different interfaces. You may need to choose something specific. For mine and my setup, just with a standard VM, I don't need to do that. And for the ports, you can basically specify whatever ports you want to use. I'm simply going to use 27,000 to 27,005. Now, I believe the limit that you can do on that is 1,000 ports per IP address. I think I tested that earlier. But if you think about it, you're not really going to need more than 1,000 ports, but it is there if you do need it. So this is only going to give me a range of 5 ports, so it might not be great for a large server setup. You might want to have hundreds of ports, for example, but if I click submit, it's automatically going to now create all of the allocations for what I just said. So you can see 6 ports were created for 0.0.0.0. Great. Obviously, you can come back and change that if you want to. You can add new nodes with more, all those sorts of things. The next thing is, now we've got those allocations in place, is we need to go to configuration. And this is the configuration that I was talking about earlier. So this is basically making the connection from the wings. If you remember, if we go back to Portainer and we go to here and we go down to the wings, it's just sat there not doing anything because there's no configuration file available to it. So that's where we get it here, and handily it actually generates this for us. So we can pretty much take all of this verbatim from here, and we can copy that now and put it into our terminal. So what I actually do here is I've copied this and then I've created a notepad file. And in that notepad file, there's some important additions, and we'll go through that now. Now, I basically copy and pasted from what's behind on the web page all the way down to here. The important bits from what would defaultly be on a vanilla config is we've changed the port here to 443, and we've changed the remote to match what our DNS entry is on the traffic label. Now, the bit after this is all the bit that I've added, and this is why it's important that we pick a network that it's on that is unique and not overlapping. If you don't specify this, odds are you're going to get an overlapping network. You'll see that error in the container logs and you can't go any further. So if you remember back, I created this Wings 0 network and I've just specified it here. So I've set the interface to be the first IP in that address space. I've set the DNS server critically, that first one. That's actually my internal DNS resolver, my Pi-hole. So it knows where panel is, it knows where Wings is, etc. We know that the name of the network is Wings. We know that the other one, the network mode for Wings, is there. And then for the actual interfaces, we know that it's a /16 because that 01 sits in there. And the gateway as well is the first IP address, that interface address. Once that's all done, we are ready to rock and roll. There's also some additional options at the bottom. I've left those in, but I didn't actually have to use them. And that's for our good old friend, Mr. Cause, who often steps in to ruin the party with that cross-origin security setting. So with this in mind, I'm going to copy. And then we're going to head back into our terminal, and we're actually going to paste this in the location that it expects. So back into the terminal. Let me just clear that. We want to navigate to cd, etc, and then Pterodactyl. Now, if we list here, there's nothing in there. So I'm going to do a sudo nano, and then I'm going to do a config.yaml. And then in there, we're going to paste those values. So now all of that is pasted in there. Everything is as we expect. So I'm going to save that with a Control-O. That's now done. Control-X to get out of there. And what we need to do now is head back into our Portainer, and then we want to reboot this Wings container. So going back to containers, we can go down to the Wings, and then we can restart it. Now, once we jump back into the logs for this one, we can now see, hopefully, that we don't get that red error message, and we didn't. Because we got here, the SFTP server is listening and it's using that public key. So with any luck now, I can go back into Pterodactyl. I can then click on nodes and we should get the all-important green heart. Yes, we did. Excellent. So now that has a connection. And if we actually click on Wings, you'll see here that it's got the daemon version. It knows it's a Linux machine and it's got 4 CPU threads. It's got the RAM that we expect. Perfect. It should also show things like the allocations we still set up. Yeah, all that's working. Excellent. So basically, we now have one node set up, and you could repeat that exact same process for as many nodes as you want. If you're doing that in the cloud, you could have plenty. If you've got a beefy home lab, you could also set up lots of different VMs, etc. But there's nothing actually running on that at the moment. So what we actually need to do is head into servers. Now, what I'm going to show here is not exhaustive. I'm simply going to set up a Minecraft server. There are lots of different servers that you can set up and that are supported out of the box. But you can find all the information for those on their website. But pretty much it's exactly the same process. They've made this really straightforward and simple within the web UI. So I'm going to give this server a name. We're going to call it Minecraft. That makes sense. We need to set a server owner. Now, I've only got one admin user, but if you wanted to, you could obviously head over here into users. You could create new users, set permissions, etc., and then specify who owns this server. So I'm going to keep this simple and make the video short, and I'm just going to use that admin user, but do note you can change that if you want to. Now I've set up a single node, so wings. It's automatically populated with that one, but if you had more than one, you could obviously use this one here, and you could select from which location, which node you wanted to, and also you can also choose which allocation for port you want to. I'm just going to default to the first one that's available, but you can obviously choose which one you want. And then you've got some options here around database limits, allocation limits, and backup limits. I'm keeping this just as default just to show you this demonstration, but do note that if you need that granular control, you do have it there. Similarly, on resource management, you can limit the CPU, you can pin to certain cores. I'm going to give this one just 1,000 megabytes of memory and 1,000 megabytes of disk space. Remember, I only had 2,000 for this demonstration. Obviously, you want to go and check what it is that you're running. You need to understand a little bit about how resource intensive your server is going to be and make sure you plan ahead. It's probably a good idea to give it some over allocation just so you don't run into any pitfalls. And you might also, in the other sense, you might want to put an out of memory killer such that if one server becomes a bit of a hog, it will kill the process. Or maybe there's a fault in the server, a memory leak, etc., and you don't want it to wipe out all of your game servers. Next, we go down to the other part of Pterodactyl, and the concept still with an avian theme of nests. Now, we've got the panel, we've got the wings. Now the nests, so the nest is basically the game server. So for this, I think default support, we've got Minecraft. If we go to the source engine, we've got the eggs. So the eggs are basically the games that run on those servers. So within here, for example, Source Engine, you've got Team Fortress, Garry's Mod, Ark, Counter-Strike, etc. And a few others. You can set up some voice servers, which is pretty cool, TeamSpeak and Mumble. And also you could set up, say, a Rust server. So for this demonstration, I'm simply going to choose Minecraft. I'm going to just use the vanilla Minecraft, but you do also have Forge, Paper, Bungee Cord, and Sponge, which is pretty awesome. So I'm just going to leave that as is. Everything else is going to be the default setting, but you can do some startup configurations here. So if you're used to doing this elsewhere, or you've got some specific startup command you want to run, you can obviously run it in here and it's compatible with Pterodactyl. Now again, bottom right behind my lovely face is the create server. So I'm going to click create server, and fingers crossed it goes off, it creates this server, and there's something extra awesome about this. Now that we've got this and it's installing, we can actually click this little button here for a pop-out. And now, because we've got a connection to that server, i.e. it has its own IP address, its own ports, we can actually dial as though it's a container straight into this Docker instance, which is awesome. So now this node, and again, you can have lots of different nodes, we can dial straight into that node and see exactly what's going on in there. Now, for anyone who's familiar with Minecraft, this just looks like a standard setup for Minecraft. So this is going to take a little bit of time depending on your internet connection and your resources, but it should follow the exact same process. And you can keep me right on here. You can see the uptime. So I'm just going to get this run in the background, and when it's finished, I'll come back and we can talk through it. But one thing whilst it is doing that, you can see along the top that this then becomes basically a web browser for that server. So for example, when this completes, you can click on files and you can see all of the files that are associated with this web server. So whilst this hasn't actually finished, you can still see all of the common things that you would expect: the server jar, the server properties, the logs, the libraries. And this is basically a container now that it's created. We can see there isn't a database on this one. We can see the backups. We can see the network that we assigned. We can do any startup variables that you may wish to add to this server. There's further settings in here if you want to set those for things like the username and the admin, the server address, etc. And if we actually look back in the console, we can see that that's still continuing and we have a front window into the console itself. And now the bit I was actually saying earlier, we have to accept the EULA for Minecraft. Now the part I mentioned earlier was it actually spins up a container. So if we go back to Portainer now, and I go to these containers, fingers crossed we should see something with a funny name. And there we go. It's right at the bottom here, and it's Pterodactyl and Yolks Java 21. Now again, if I move my face, we'll see that it's 172.50. It's taken its own IP address and it's on that port 27,000. So that is the server that we've just set up. And now because Pterodactyl has access to the Docker sock, it can actually then spin up containers as and when it wants. And that's exactly what it's doing in here. So if we just scroll down on this page, you can see some handy CPU load and memory consumption. This is still doing its thing in the background. I've only set 2 cores and I've only given it a gig of RAM, so it's going to take a little while to set this up. I'm going to skip ahead now and I'll see you once this is fully deployed, and then we'll actually fire up Minecraft and connect to our own Pterodactyl server. So now that that's almost completed and you can see that it's going ahead and creating a new world because it's a new server, we could obviously go back now to Pterodactyl itself, so back into the main panel. We could create a new server. So you could even create, say, hey, I want another Minecraft server. And so we could call that one Minecraft 2. We could then, as you see, 27,000 is no longer available. It's automatically enumerated to 27,001, the next available port. And then we could set all of these variables again, and we could just spin up a new server. Then you could have Minecraft 1 and 2 on the same node on the same panel. So you can start to see really how you can quickly scale this up once you've got the infrastructure in place. You could also change this to be a different server. So we could then quickly set up, say, a CSGO server or a Team Fortress server, and it's all within this panel, all running on the same nodes, all managed through the same single user interface, which is really powerful. Now, the one thing that you will need to do if you're going to be port forwarding this over the internet, I'm not going to go through the port forwarding in this video because I've covered it in several other videos, and usually that's only specific to if you're using that platform. So if you're using something like pfSense, OpenSense or Sophos.xg, go and check out my videos. But the process for port forwarding is pretty simple. It's exactly what you'd normally do. It'd be your external IP address. You would forward it then to this internal IP address that's specified on this server. So for me, it would be my Docker IP and then port 27,000 for Minecraft, and I'll show you connecting to that in a minute. The one tricky part, if you want to host, say, several Minecraft servers all under the same DNS name, you will have to create an SRV record on your domain host, so your external host, and that just simply states basically the port you want to connect to. Every server does need a unique port, and you just saw that with 27,000 and 27,001. For most people in a home setup, you won't want to listen to what I'm talking about, but if you're going to want to use this, say, in a cloud setup where you might want to host lots and lots of games, you might need that. So do go up and read on it. Anyway, so that's now completed. So we're in a position now where we can load up Minecraft and we can add our own server. So if I fire this up, ignore that one. That's one I've already connected to running in Kubernetes from an earlier video. And if I click add server, let's just call this one Pterodactyl. What we need to do is specify the IP address of my Docker host, which is 192.168.200.50. And if you remember, we're running this on 27,000. Now, I could actually in here put a DNS record because again, it can resolve the IP address of this host, so I could have Minecraft pointing to there and just use that instead. Now we aren't using the standard port here for Minecraft, so I will need to add the port, but again, you can use an SRV record if you wanted to. So hopefully if I click done, yep, that's added. And now if I hit the play button, hopefully we see me connecting in the background. Yep, there we go. I've connected with the user ID. This isn't going to be the most performant server. This has only got 2 cores and a gig of RAM, so it might be a bit clunky, but in terms of smoothness, operability, working, you can see also in the background the CPU load is hitting 180%. That's nearly using 100% of both cores, and the RAM will start to spike up as it starts generating more terrain. But this looks perfectly fine. We can run around and do things. I must admit, I don't know anything about Minecraft. But yeah, there we go. Simple as that. We've got Pterodactyl running. we've got a Minecraft server spun up that you can now manage through a friendly web interface, and you can spin up as many instances as you have resources for. So thank you very much for watching. I hope you found that useful, and hopefully I couldn't see too many guides on having this set up in Traffic, which if you've been following my videos is probably what you're emulating. So let me know if this is something you're going to use. Let me know what servers you're going to set up and how you're going to configure it, etc. Do note that I will get onto Pelican, which I mentioned earlier, which is where a number of the developers for Pterodactyl have gone to. That seems to be doing things slightly differently. They seem to be doing a lot more around some of the security features and adding additional bells and whistles. So I'm really keen to see where that's in. Apparently it's still in beta, but apparently it's pretty stable. So stay tuned, I will get onto that. Anyway, as always, if you've liked this video, please give it a thumbs up, hit that subscribe, and I'll see you on the next one. Take care, everybody.